All right, today we're looking at lesson 11. It's more about similar triangles, and it's a little spaced out weird on the page just to make sure we have enough room for everything. So for this classwork exercise, this as in the diagram below, you have triangle ABC and triangle AB prime C prime. You'll notice that both triangles share the same uh, A, right? They both share this point right here. We call these nested triangles or triangles that are like fitting inside each other, kind of similar to like the Russian nesting dolls concept. Anyways, we're going to use this info to figure out a couple questions here. So A up at the top right here says, based on the information given, is triangle ABC similar? We're talking similar, so not congruent, but similar to triangle A, B prime, C prime. So again, the bigger triangle is the smaller triangle or the original, similar to the bigger triangle, based on this information we're given. So we're given this side length right here. We're given this side length right here. We're given this side length right here, so that B prime to C prime and B to C, those correspond, right? These two guys correspond to each other, right? And we're given this side length right here, but we're not really given anything else. We know that angle A is going to be the same because it's the same for both the big triangle ABC and the smaller triangle AB prime C prime. So we have one angle. We don't have a second angle yet, and we're not given any other information about specifics, so there's no way to prove it. So at this point, my answer is no. Based on just that information, I don't have enough, right? So no, not enough info, or we need more. Okay, we need to be able to confirm that there are in fact two angles that are the same. Angle theorem, right? Or the two angles. If we know the two, then we know all three. And if we know that all three angles match for all three corresponding angles of both sets of triangles, then we know that it's similar. Part B down at the bottom here says assume, right there, says assume that the line containing B to C is parallel to the line containing B prime C prime. What with this information can you say that they're similar now? So what we're really looking at is this line here. If it's parallel to the other line, that means that we could in fact translate it or slide it over and it would still match. If that is really the case, that means that this angle here is identical to this angle here, because if it's parallel, that means that it touches that line that goes from A to C and A to C prime. It touches it at the exact same angle, the exact same point, which means that that set of angles is in fact a matching or corresponding set. That also means that this angle down here would match with this angle here because we already have two angles, right? Or again, because it's parallel, when we slide it over, since they both contain the same line to start with, that would make sure we know that all three angles are there. So in that case, would we then be able to tell for sure that it's similar? We would say yes, right? We have at least two angles to prove that it's similar. Looking at part C, which is right here in the middle here, it says given that they are similar. So now we have been told they are similar, right? Once it says given and it tells you that that's the case, you don't have to prove it anymore, right? Before this said is it similar, and then this one said assuming B part B right here said assuming that that line is the case, can you say that it is similar, right? And there's my question mark. Now this is saying it is similar. There's no question about it. We're going to be told they are similar. You're now going to find the length of side A to C prime. So that's, we have A to C, which is this big one here, which is 6. And so we're going to find this smaller one here that goes from here to here. That's A to C prime. So we can do it a handful of ways. One of the easiest ways to do it is to look for a scale factor. So once we have a scale factor, we can now figure out how to go from one to the other. So right now we have one pair of sides that correspond, right? CB corresponds with C prime B prime, and we have a 2 and 8 ratio. Now again, we're going from the original to the copy, and we would go from an 8 to the number 2. So when I'm looking for a scale factor, remember scale factor is a multiplier, right? I know you'd go, oh, well, you just divide by 4. 8 divided by 4 is 2. That's true. So if we're looking for a multiplier, we would flip that on its head. Instead of divide by 4 over 1, we'd multiply it by 1/4. 8 times 1/4 is 2. If we went from the copy to the OG, then we would flip this 1/4 over and it would be 8 times 4, right? 2 times this 4 would be equal to the 8 going that way, right? So again, we're trying to find this smaller copy number here. We're trying to find this copy number here. So that's why we're going from the big to the small. So we're going to use our scale factor of times 1/4. So our scale factor in this case is 1/4 or 1/4. So now that I have that, I can take my bigger chunk, 6, I can multiply it by my scale factor, which we said is 1/4, and I can come up with my answer, which is that smaller copy. 6 times 1/4 is the same thing as saying 6 divided by 4. 6 divided by 4, 4 goes into that one hole with a 2 remainder. 2 out of 4 is the same thing as 1/2. So it would be 1.5 or 1 1/2. They didn't give me units, so I would say units. If they gave me feet, inches, whatever, then I could use that. Okay, and the last one, D, says given, so again, we're being told for sure that they are in fact similar. Given that they're similar, determine the side length of A to B, excuse me. So we have A to B prime, that's this one here. So we're looking for this big guy here. So now we can use that same scale factor that we had, but in this case, now we're going from the copy to the original. So now our scale factor is not 1/4, it's 4/1, or our scale factor is 4, because we're going backwards either the direction, right? So I would have 2.7, which is my smaller copy, times my scale factor to get bigger. Remember, the OG is bigger, right, of 4. And I would end up with 10.8. I'm on you. There we go. And again, we don't have any units with this, so I'd say 10.8 units. Looking at this next one here, says in the diagram below, you have triangle ABC and triangle A prime, B prime, C prime. So these are not nested anymore, so we don't have anything as a given. Use this information to determine this. Based on info given, is triangle ABC similar to triangle A prime, B prime, C prime? Explain. So we have a 92-degree B, and B prime is 92 degrees. These match, so there's our first angle that are corresponding, that match each other. And we have an A prime and an A, and they're both 59 degrees, so they match. Therefore, we have at least 2 angles, which means we have all 3. So we can prove for fact that, in fact, yes, they do match. And again, that would be the angle-angle theorem, right? Meaning that if we know 2, we know all 3. And as long as all 3 angles in a triangle match, that they are at the very least similar. Part B says, given that they are similar, so now it says regardless of whether or not they were, which they were, but now they're saying for sure it's given, right? They are similar. Determine the side length of A prime, C prime. So same thing, we could look for a scale factor here. And if we're looking for scale factor, again, looking at OG, original geometric design, to the copy, if we did that, right? Take a look at the OG. It's the one that does not have any primes on it. Only one that I am given here is AB, right? So that's 3.2. And the copy with the primes is 512. So we could find our scale factor going from 3.2 to 512. If we look at this, we see that we're getting bigger going from the original to the copy. The copy is a larger copy. So that means my scale factor has to be a number that is greater than 1. Or it has to be bigger than 1 because it gets bigger. So the way to do this would be to take 512 divided by 3.2. And when we get 512 divided by 3.2, we get a scale factor of 1.6. We can now use this 1.6 to go from, what is it? It says determine the side length of A prime, C prime. So we're looking for this big thing here. We are given AC of 6.1. We know that when we multiply by our scale factor, we know it's a bigger version. That's why it's larger than 1, and it's 1.6. And so when we do 6.1 times 1.6, we get 9.76. And again, units, because I don't see any other units there, right? And same thing is true for C. It says given that triangle ABC is similar to triangle A prime, B prime, C prime, determine the length of side BC. So again, we're looking for a scale factor. In this case, though, you notice that we are now trying to find this side here, which is we're going from copy to the OG. Remember, copy is larger. So let's use our numbers from before, right? Because those were given to us, so we guarantee that those are right. Even on the, we got this answer, but on the off chance that we were to get it wrong, the easy way to double check is we would use the stuff that's given to us to make sure that we have everything. So to go from 512 to 3.2, we know that we're getting smaller, so it should be a scale factor that's less than 1, right? Scale factor should be less than 1, or it's going to be a smaller number. So the way we would do that is we would do 3.2 divided by 512, and when I do that, 3.2 divided by 512, I get 0.625. So that's my scale factor, 0.625. Now I can take my side length that I know, which is the copy version, 8.96, times 0.625. And I get 5.6. Right, 5.6. And again, we're talking units. And just for looking at it for purposes here, there's another way to do it. There's a bunch of different ways to do it. So we're finding a scale factor here. To me, that's the most obvious. But you can also you can set up a cross multiply solving equations concept. So where you could label, let's say for B, right? The side we're looking for was that 9.76. It was this guy here. So we'll label that X, and then we'll label this guy Y, just so we kind of see what's going on. So one thing we can do is we could also set up a solving equations, or excuse me, a cross multiply problem. So taking the thing that I don't know, my X, right, and putting it over its corresponding side, which is this piece here, right, the 6.1. So that's what this is, right? It's my copy over my OG. And then 512 is my copy here over my OG, the one that I do know. And then all I do is I'd cross multiply. When I cross multiply those things, I come up with 3.2x equals 31.232. Solving equations, all we would do is divide by 3.2. Whatever you do to one side, you do to the other, right? And we'd be left with x being equal to 9.76. You'll notice that it's the exact same answer that we got here. So it's the same answer, right? Same correct thing, just a different way to do it, right? Is that guy. So the same thing can be true for part C. Remember, we labeled it as a y. So again, I can take the thing that I don't know. Again, remember, this is my OG, this is my copy. So in this case, I'm taking my OG divided by, or excuse me, taking my copy, 8.96. That's this guy right here. Copy over my thing I don't know, my OG. And again, copy 512 over 3.2, the OG. And again, cross multiply. I get y times 5.12 equals 8.96 times 3.2, which equates to that. Remember, from here, solving equations, one step. All I do is divide by whatever's in front of the letter, 512, whatever I do to one side, do to the other. And I would be left with y equals 5.6, which, hey, look at that. It matches the exact same thing here, right? So again, it's just a different way to do it. Same concept. Looking at this third one here, it says in the diagram below, you have triangle ABC and triangle A prime, B prime, C prime. So again, not nested. Use this info to answer the question below. Based on the information given, is triangle ABC similar to triangle A prime, B prime, C prime? Explain. So right now we're given one angle, right? We're given angle B and corresponding B prime. They're both 101 degrees. We don't have the angle for A or A prime. We don't have the angle for C prime or C. We don't have any of that info. And if we were to use this, we could try to set up a scale factor concept to look and see whether or not it matches. So again, BC, this one here, would match with B prime, C prime. So I'd be looking at 4.6 compared to 11.66, and I'd look for a scale factor. And then I could also look for a scale factor for this one here, AB. So that's 5.3 compared to this A prime, B prime. That's 10.58, right? Or we could set up again a solving or a cross multiply solving systems of equations. In this case, the answer is no, it's not enough given information. 10.58, right? So that's my second set of lines, my copy. We'll label that there, copy and OG. And that's my copy over my OG equals my copy over my OG. So again, I'm setting up the AB side, right? Prime on top and no prime on bottom, compared to my BC side, prime on top, no prime on bottom, or copy on top, OG on bottom. And again, if I cross multiply these, if the scale factor is the same for both of them, then I should have something that they equal each other. When I do that, I get 48.668 is equal to 61.798. That is not equal to each other. Therefore, there is no scale factor. That's why I double down on the concept that the answer is no, they are not similar, because there's no scale factor that exists for both of them, and we don't have more than one angle, so we can't use anything else to prove that that's there. Nothing said that it was parallel or we could slide it around. So in that case, no, they are not similar. And with that, we are off to problem set.